Okay, ladies and gents, so this revision video is all about differentiation. So, I've actually done this question quite recently on another video as part of the 2015 paper, but it's worth going through it again just to have a look at the key points. Now, what I would say about these differentiation videos and calculus videos is fantastic if you can do the first bit of the parts A to these questions, but if you can't, don't get hung up because part B is completely independent of part A. And what I'm going to do in this video is I'm going to do part B and part C first, or certainly in this first question, to show that you don't need to be able to show this thing here. So, use calculus to minimize or find the minimum cost. Now, whenever it says use calculus to find either the minimum, the maximum, or turning point, stationary points, it means that we differentiate and we set it equal to 0. I'm just going to repeat that because that is the key thing here. If you use calculus to find the minimum or the maximum, we differentiate and then we set it equal to 0. So when we differentiate, if we've got C, we're going to do dC by dr. So we differentiate C with respect to whatever the variable is here, and the variable is r. So dC by dr is what we're going to do. So what we're going to need to do first is to get rid of that r, bring it up there to make it -1. So remember, this is part B we're doing first. So if we differentiate that, we get 12 pi r minus 300 pi r to the -2. And if we simplify that, that's going to be 12 pi r minus 300 pi over r squared. So that's differentiated, that's going to be some marks, and we set it equal to 0, that's going to be some more marks. And then we've got to solve it. So what we're going to do is we're going to bring this over to the other side. So by doing that we get 300 pi over r squared equals 12 pi r. And then we're going to bring this r squared up to the top and divide both sides by pi. So we get 300 equals 12 r cubed, because r times the r squared is going to be r cubed. Divide by 12 and we get 25, so we get r cubed equals 25. So r equals the cube root of 25. And notice it says here, it doesn't say find the value of r, even though we have to find the value of r. It says find the minimum cost of polishing. Now if you read the question carefully, it tells you that the cost of polishing is given by this. So this is how we find the cost of the polishing, and what we've done is we've found the value of r that finds the minimum cost of polishing. So by differentiating set it equal to 0, that's how you find the minimum, and what we've done is we've found our value of r, which gives us the minimum. So what we now need to do is substitute this value of r back into this equation here. So we then write down that the cost equals 6 times pi times by cube root of 25 squared plus 300 pi over r. And what I'm going to do is I'm going to do that on my calculator. So just bear with me whilst I do that. So 6 times pi times cube root of 25 squared plus 300 pi divided by our value. And it says given your answer to the nearest pound. So if I do that, I get 483.48 in pounds and pence, which the nearest pound is 483 pounds. Now, on all these calculus questions, they always do the same thing. They say use calculus to find the minimum or the maximum. And again, I'm going to repeat it again, as I'm going to do throughout this video. That means that we need to differentiate when we set it equal to 0. What they also ask every time is to state whether it's a maximum or a minimum, or justify, in this case, that it's a minimum. And the way we do that is we differentiate again, and we sub our value of r into it, or sub our value that we've got into it. So we've already got up here that dC by dr equals 12 pi r minus 300 by dr squared, which equals 12 pi minus plus 300 pi and r to the minus 3, which I'm going to write down as r to the 3 underneath. And then what we do is we set r equal to the cube root of 25 in here, and then see what we get. So if we do that, we get 12 pi plus 300 pi divided by what's going to be 25, because that's going to be the cube root of 25 cubed, and we get 75.39. Now, sorry, 398. That was being correct rounding. Now, if our value that we get is above 0, it's a minimum. If it's below 0, it's a maximum. So we can say that d2c by dr squared gives a positive value. Therefore, it's a minimum. And then if we have a look at the answers for this, it's only part B and part C, remember, that we're doing at the moment. So we've got 2.92, which is the cube root of 25. We've got 483. Then it says that d2c by dr squared is greater than 0, positive, so it's a minimum. So again, by doing all this, what we see is that we don't need to do part A to do part B and part C. And that's the key thing. Please don't think that you need to be able to do part A to do part B and part C. Even though it's going to be one of the end questions, it's still something that if you can do part A, fantastic, get yourself 4, 5, 6 marks, however many it's worth in this question. But if you can't, as soon as they start talking about calculus to find a minimum or a turning point or a maximum, that's what you do. We differentiate, we set it equal to 0. Anyway, for the sake of it, I'm going to go through part A to show you how to do this. So what we've got here is we've got a cylinder, and we're told that the volume, so what we're not told is what the radius is, so we're going to have the radius as r, and we're going to have the height as h. Now what they've done is they've told us that the volume is 75 pi. So what we're going to do, the first thing, is if they don't give us anything else, but they tell us that the volume is 75 pi, we're going to get a mark for writing down an equation which works out the volume and then setting that equal to 75 pi. So to work out the volume of this, we're going to work out the flat shape, which is a circle, which is pi r squared, then we're going to multiply that by h, and that's going to be the volume of our cylinder. Now you tell us that that equals 75 pi. So that's going to give us 1 mark, and what we can do, just to help us out for later, we can simplify this by dividing through by pi. So r squared h equals 75. We're going to just put a pin in that, leave it there for a second. And this is the cost of polishing the surface area of this glass cylinder is £2 per centimetre for the curved surface area and £3 for the circular top. So what we're going to do is we're going to work out the surface area first of all. So if I give us some more room here, because we don't need this bit anymore. Okay, so the surface area. Surface area is the top and bottom, which is pi r squared, which is the top. Then we've got the bottom as well, so there's going to be 2 lots of that. Plus the curved surface area, which again, if we got the flat shape around the outside, if we cut up where I've done the red dotted line there, then open it out, it would be a rectangle. Now the height would be h, and this top bit here, imagine unraveling this here, that's going to be the perimeter of the circle, the circumference of the circle. So the way we work out the circumference is pi times by diameter, and the diameter here is 2r. So the circumference is pi times 2r, or 2 pi r. So the area of this is going to be width times height, so that's going to be plus 2 pi r h. Now we've got to work out the cost So the for the top and the base is £3 per centimetre squared. So this is the area of the top and bottom, so we're going to multiply this thing by 3, which gives us 6 pi r squared. And it says that the cost of the curved surface, which is this bit, you're going to multiply it by 2 because it's £2. So you're going to do 2 lots of that, which is 4 pi rh. Now if we have a look at what we're trying to find, 6 pi r squared maps with our 6 pi r squared there. However, this doesn't include this, and the reason being is that this one up here doesn't involve h, and R1 does. What we know from the other thing they gave us is that r squared h equals 75, so we can rearrange this to get h equals 75 over r squared, to substitute in and get rid of the h. So if we substitute in the h into here, we get, so we've still got the 6 pi r squared, 4 pi r, and we substitute in times by 75 over r squared. Now 4 times 75 is going to give us 300. That r is going to cancel out with one of these r's. And so we get 6 pi r squared plus 4 times 75 is 300 pi, and then the r on the top cancels out with one of the ones on the bottom, leaving just with one on the bottom, which is what they've given us here. Okay, so that's that question. Now what we're going to do, I know I've taken quite a while on that question, but I wanted to stress certain points. So hopefully we should be able to go through the next few questions a little bit quicker. No idea why that one's there. That's not what we're doing in this video. Okay, let's have a look at question 3 then. Okay, so we've got to show that y equals that down there. And then we've got to hence show the perimeter. Right, now just before we go and do part A and part B again, fantastic if you can do these parts here, that gives you 6 marks. However, if you can't, don't worry, because if you have a look at part C, use calculus to find the minimum value of P. So calculus to find the minimum value of P. I've got P here. To find the minimum value of this, I differentiate and set it equal to 0, exactly like we did last time. But let's go through and do part A and part B first this time. I'm trying to make this a little bit smaller. There we go. So let's write down stuff that we know. We know that's an equilateral triangle. So we know that this is x here. We know that that's x. We know that this is y. Okay, we've got to work out the perimeter at some point. So let's get what this curved surface area is here. So the circumference equals pi times by diameter. From diameter here is x. So the circumference of the whole circle will be pi times x, but we've got only half of the circle here, so it's going to be, so from C round to E is pi x over 2. Okay, so we're told that the area of all of this is going to be 50 meters squared. So let's have a look at that then. So we've got 3 areas. We've got 1, 2, and we've got 3 here. So let's work out the area and set that equal to 50. So we've got the circle first of all, which is pi r squared and divided by 2. So the area of the circle is going to be pi times by the radius, which in this case we know is x over 2. So pi x over 2, but the radius got to be squared. And then we're going to divide that by 2. Then we're going to add x times y, which is number 2. So that's number 1, that's number 2. Then we're going to add number 3 onto it. And 3 is going to be that equilateral triangle. Now we should know that the area of a triangle is half AB sine C. Now if it's an equilateral triangle, we also know that this angle here is going to be 60. So it's going to be half times A times B, so that's going to be x times x, so that's going to be half x squared sine C. And you should know that sine 60 is root 3 over 2. And if you're not sure about y, if you imagine an equilateral triangle cut down the middle, but each side is 2, if I just take this bit here of the triangle, that's going to be 1, 2, and then using Pythagoras, we've got root 3. We know this one is 60, this one is 30, and we've got to do sine 60, so we've got to do the opposite over the hypotenuse, so that's going to be root 3 over 2. Okay, so going back to it, we then set this equal to 50. So we know that the area of the pool is going to be the area of 1 plus the area of 2 plus the area of 3. Now let's tidy this up. So that's going to be pi x squared, and then 2 squared is going to be 4, then divided by 2 again is going to be 8, plus xy, plus, and if we tidy this up here, that's going to be root 3, root 3x squared over 4, which equals 50. And what they've then got is they've rearranged that to get y. So let's take everything else onto the other side. So we've got xy equals 50 minus root 3 x squared over 4 minus pi x squared over 8. Now we can see here that they've taken 8 outside, so what I'm going to do is I'm going to change this to 8 and put 2 on the top, so 2/8 is the same as 1 over 4. So then, if we divide both sides by x, we get y equals 50 over x, which is the first bit spot on. If we divide the next thing by x, that's going to knock out one of these. So that's going to be 2 root 3 x over 8, minus if we take an x off this one, we'll divide by x on this one here, you're going to get rid of one of those x's there. So it's going to be minus pi x over 8. And then finally y equals 50 over x. Now they've taken out an x over 8. So if we take out x over 8, that's going to leave us with 2 root 3. And if we multiply this, we're going to get a plus pi. Because remember, when we have taken out the x over 8, it's a minus x over 8 we've taken out. So minus x over 8 times this makes minus 2 thirds, minus 2 root 3 over 8x. If we times this minus by this one, we're going to get minus, which is what we've got on the top. And this is what they've asked us to find. Now, it then says, hence show that the perimeter of the pool is given by this. So let's get rid of everything that's on the screen at the moment. Again, you can always come back in the video to this. And the perimeter was x, x, y, y, and then what did I say that was? Circumference equals pi times diameter, which is pi x then divided by 2, because it's only half of it, so pi x over 2. So the perimeter equals x plus 2x plus pi x over 2 plus 2y. And we know that y is this thing here, so it's going to be p equals 2x plus pi x over 2 plus 2 lots of that chap, so that's going to simplify it to this. So equals 2x plus pi x over 2 plus, if we multiply the 2 out, it's going to be 100 over x minus x over 4 lots of pi plus 2 root 3. And let's go on and simplify that some more. 2x plus pi x over 2 plus 100 over x minus x pi over 4, or pi x over 4, I guess I should write that as, minus 2 root 3x over 4. And then again, tidying that up. By the way, because we've got a pi of 4 here, everything's going to need to be over 4. So let's make that 2 over 4. And then let's make this 8 over 4. Now if we do that, we can bring the 100 over x out, then plus, everything else has got an, so we've dealt with that bit, then everything else has got an x over 4 in it, so let's bring out x over 4, and then this times by 8 makes the first thing. This times by 2 pi is the next thing. This times by pi, or minus pi, is the third thing there. And this times by minus 2 root 3 is going to be the last one. And then if we simplify 2 pi minus pi, we end up with just pi, which is what they've got down here. Again, because they've said show that y equals this thing here, we can actually use this to do part B even if we can't do part A. But again, all of that, don't worry too much, because what we're now going to do is we're going to have a look at part C and part D. And that's the key thing here. Because again, these questions are exactly the same. This, I believe this is the 2014 paper. So use calculus to find the minimum value of p. So what we're going to do is we're going to do dp by dx. So let's get x up there, make it to the minus 1. So if we differentiate, we get minus 100 x to the minus 2. Plus, if we differentiate this, remember this thing here is just a number. So if we have that over 4 is just a number, I mean that could be just the number 3. So if we differentiate 3x, we just get 3. So when we differentiate with it's just x to the power of 1, we get rid of the x and we're just left with that number. So we're left with pi plus 8 minus 2 root 3 over 4. So that's differentiated. We then set it equal to 0 for another mark. So 0 equals minus 100 pi over x squared plus pi plus 8 minus 2 root 3 all over 4. I'm going to stick that in brackets. And then we've got to solve that. So let's bring this over to the other side. So 100 over x squared equals pi plus 8 minus 2 root 3 over 4. Let's bring the 4 up to here and bring the x squared up to here and then divide through by this. So stating right now another time. And we get x squared equals 400 over pi plus 8 minus 2 root 3. I really hope I haven't made a mistake here. And x equals the square root of that, which is going to be 20 over pi plus 8 minus 2 root 3. this in, and I hate to make a mistake here. 7.22, here we go. Are we ready? Okay, go now. Question 2. Question 2 we didn't do. It's question 3. Part 7.218, so 7.22. Oh, that's so good. Right, okay, so what we need to do is we then need to store that as our answer. So, bear in mind here, we haven't answered the question yet. It says use calculus to find the minimum value of p. What we've done is we found x. So we know that x equals 7.22. That's not our minimum value of p. To find out what p is, we need to substitute our value of x into our equation. So we've then got to sub in, and again, even though it's a huge equation, but I would still do it anyway. 100 divided by 7.22 to show that you're actually substituting it in. 7.22 over 4 times by x plus 8 minus 2 root 3. And then stick that all into your calculator and see what you get. Again, it's quite a significant thing that you have to substitute into your calculator here. So bear with me a second, please. I'm hoping that we get 27.7. And yeah, 27.7. Fantastic. So, that's our 5 marks. Justified by further differentiation, that p that you've found is a minimum. So just like beforehand, what we're going to do is we're going to differentiate a second time, substitute our value in, and if it's a minimum, therefore our value should be greater than 0 or positive. So dp by dx was minus 100 x to the minus 2 plus a quarter of pi plus 8 minus 2 root 3. So if we differentiate again, d2p by dx squared equals 200 over, or 200x to the minus 3, which I'm going to write as 200 over x cubed. And this thing here hasn't got any x in, so that thankfully just vanishes. So we end up just with this chap here. Then what you do is you substitute in your value of x. So let x equal 7.22 and d2p by dx squared equals 0.53. So d2p by dx squared is positive or greater than 0, therefore a minimum. So again, you can see exactly what we did last time. It's exactly the same as what we've done here. We try and fiddle about with a bunch of stuff to make A and B work, but irrespective of whether we do that or not, part C and part D are the ones that really will find or will give you the marks for doing this calculus. Okay, so let's have a look at question 4, which is mercifully a shorter question. Using calculus to find the coordinates of the stationary points. Now, stationary points are either a point of inflection, a minimum, or a maximum. So again, we're using calculus to find the minimum or the maximum. So what we do, again, differentiate, set it equal to 0. Again, that's the key message that's been sort of put across each time here. Differentiate, set it equal to 0. So dy by dx equals, so if I get that as x to the minus 2, so 2 minus 16 x to the minus 3, and then we set that equal to 0, so 0 equals 2 minus 16 over x cubed. Let's bring this to the other side, so 16 over x cubed equals 2. Do the old switcheroo there, so multiply by x cubed, then divide by 2, and we get 8 equals x cubed, so x equals 2. So that's the x coordinate, and just like in our other questions, once we've got our value of x, we need to substitute it in to find out what the value of y is. So y equals 2 times, and again I'll do it as explicitly as this, just so that you make sure that you get the mark, 8 over 2 squared. So that's going to equal 4 plus 3. 8 divided by 2 squared, 8 divided by 4 is going to be 2. So 4 plus 3 is 7 plus 2 is 9, so y equals 9. So the coordinates are going to be 2, 9. So hopefully, question 4, x equals 2, y equals 9, lovely. How much quick was that question? But again, the premise is still the same. Using calculus to find the stationary points, differentiate, set it equal to 0. I might even put that in the information box. Calculus, stationary points, or maximum minimums, differentiate, set equal to 0. I'm hoping that you're bored of hearing me say differentiate, set equal to 0, because then what you'll know is that you have to differentiate and then set it equal to 0. Okay, so question 5. The curve has this equation here, so let's write that as x to the power of a half. And it has a stationary point, but use calculus to find the stationary point. So again, we're using calculus to find the minimum or the maximum or whatever it turns out to be. So again, we're going to differentiate, set it equal to 0. So dy by dx equals 2x plus, minus 16x to the minus a half. And we're going to set that equal to 0, so 0 equals 2x minus 16 over x to the power of a half. Bring that over to the other side, so 2x equals 16 over x to the power of a half. Bring the x, we'll do the switcheroo between the 2 and the x to the power of a half there. So x times x to the power of a half is going to be x to the power of 3 over 2, and that equals 8. And then what we're going to do is we're going to do the cube root of each side. So if you do the cube root of each side, that's going to get rid of the 3 on top, leaving you with 2. Then to get rid of the power of a half, we then need to square both sides. So you've got x equals 4. Okay, so that's our x coordinate. Then we substitute it back into this to find the y coordinate. So y equals 4 squared minus 32 times by the square root of 4, which is 2 plus 20. So it's going to be 16 plus 20 minus 64. 36 take away 64. How lazy my maths teacher, I'm doing it on my calculator. Y equals minus 28. So the stationary point is going to be 4 and minus 28. What we've got to do is we've got to determine the nature. So we've got to find out whether it's a maximum, a minimum, or a point of inflection. So we differentiate that again, and we set it equal to 0. And again, I've got rid of the differentiated function. So dy by dx was, 2x minus 16x to the minus 3 over 2. So d2y by dx squared equals 2 plus, if we times 16 by 3 over 2, divided by 2 is 8 times by 3 is 24, x to the 5 over 2, x to the minus 5 over 2, which I'm going to write down as x to the 5 over 2 underneath. And then what I'm going to do is I'm going to substitute x equals 4 in there. I get d2y by dx squared equals 2 plus, okay, x to the power of 5 over 2, 4 to the power of a half is going to be 2, and 2 to the power of 5 is 2 4, 8, 16, 32. So this, when you substitute 4 in, goes to 32. So a plus 24 over 32. And that equals 2.75. Now, so we know now that d2y by dx squared is 2.75, and d2y by dx squared is greater than 0. Therefore, it's a minimum. So let's just double check that one. So yeah, 4 minus 28, that's a minimum. Oh no, I said it flippantly, but please use your calculators and don't just assume that you can do things in your head, because it's not worth making a silly mistake on your exam, so make sure you do that. Encourage yourself to be lazy. Okay, so let's have a quick look here. I've got a few more questions to do, maybe 3. Right, so the next one, use calculus to show it's a turning point, so I'm going to differentiate it, set it equal to 0. Let's put that as x and minus 3 up there. So dy by dx equals, the 6 goes, the minus 3x goes to minus 3, and then that's going to be plus 12 x to minus 4, set equal to 0, so 0 equals minus 3 plus 12 over x to the power of 4, move this to the other side, or sorry, move this to the other side, so we get 12 over x to the power of 4 equals 3, switch these two around, so 12 over 3 is 4 equals x to the power of 4. We can square root both sides, and to do that we get x squared equals 2, and then x equals the square root of 2, which is what they've got there. So find the x coordinate of the other turning point q on the curve. So of course, when we do this, we've got, when we do the square root of 2, we've got either the positive square root of 2 or the negative square root of 2. So we've got to find, oh, so there's the x coordinate, so there's just minus root 2. Find d2y by dx squared, so here's dy by dx, so let's differentiate that again, d2y by dx squared equals minus 48 x to the minus 5, hence or otherwise, since state with justification nature of each of the turning points P and Q. So if P equals root 2 and Q equals minus root 2, we've got to substitute both those into this. So minus 48 over x to the power of 5. With this one, if you let's go minus 48 over x to the power of 5. So if we substitute p into that, d2y by dx squared, it's going to be negative divided by something positive, so it's going to be less than 0, so therefore that is a maximum. If we substitute something negative in there, something negative to the power of 5 is still going to be something negative, so a negative divided by something negative, that will lead us to d2y by dx squared being greater than 0, and therefore it will be a minimum. So if we have a quick look here, yeah, square root of 2, minus square root of 2, differentiate it, and we get that there. D is greater than 0, so it's a minimum, less than 0, it's a maximum. If you see here, it says the second differential of y need not be evaluated, but must be correct. And so you've got to say that root 2 gives a negative. You don't need to say what's the y value is when you substitute in root 2, but you just need to say that when you substitute it in, it will be a negative, therefore it's a maximum. Okay, next question. Again, it's one of these ones here, so hence we're going to show that y equals this, p equals this. It doesn't matter if we can do those marks or not, because 7 of those 13 marks are using the calculus to find the minimum. Again, differentiate, set it equal to 0, find out what value of x is, substitute it in, and then D is actually a little bit different this time. So let's have a quick look. The area of the flower beds is 4 meters squared. So let's work out the area then of the whole thing. So we've got this here, which is xy. This thing here is going to be xy. And if this is, the radius here is x, this is going to be pi x squared divided by 4. And so we know that the area of all this add together is 4 meters squared. So I'm going to say that 2xy plus pi x squared over 4 equals 4. And that's going to give me 1 mark. And then we've got to rearrange to get y equals. So 2xy equals 4 minus pi x squared over 4. And because we've got a number here, take away a fraction, I'm going to write this number. Instead of 4, I'm going to write it as 16 over 4. And then we're going to bring this 2x down to the bottom. So we get y equals 16 minus pi x squared. And instead of just 4 being on the bottom, I'm going to multiply that by the 2x to get 8x, which is what we get there. Hence, show that the perimeter P of the flower bed is given by this equation. So if we have a look at this here, we've got we've got a bend there which is going to be the hardest bit to find. You know, that's y, that's x, and that's y. So the circumference of a quarter of a circle is going to be pi times diameter divided by 4. So the diameter is going to be 2x. So pi times 2x divided by 4. 2 divided by 4 is 2. So this is going to be pi x over 2. So the perimeter equals, if we simplify that, we've got pi x over 2 plus 2x plus 1, 2, 3, 4y. Now we also know that y is this thing here, so p equals pi x over 2 plus 2x plus 4 lots of 16 minus pi x squared over 8x. So we've got to simplify it so it goes to that. So p equals pi x over 2 plus 2x plus, if we cancel out this 4 with that and make that 2, it's going to be 16 over 2x minus pi x squared over 2. And we've got the 2x here with the 2x here, so it means that we've got to simplify the rest of it to make 8 over x. Oh, sorry, over 2x. So that cancels out to make that. So pi x over 2, pi x over 2, that cancels out. 16 over 2 simplifies down to 8. So yeah, that simplifies down to 8 over x plus 2x. So my mistake that when I multiplied out this bracket, the 4 cancelled out with a 2, so that leaves with 16 over x. And so this here simplifies down to 16 over x and pi x squared over x. So this x cancels out with this one, leaving you with this here. Hooray, you use calculus to find the minimum value of p. So now what we're going to do, that we've shown those, is we're going to use calculus to find the minimum value. So again, we differentiate, set equal to 0. So dp by dx, let's make that x to the minus 1. So equals minus 8x to minus 2 plus 2. That goes down underneath. Set equal to 0. 0 equals minus 8 over x squared plus 2. Bring this to the other side. Minus 8 over x squared equals 2. Sorry, that's going to be positive. Switch these two around. 8 over 2 equals x squared. X equals the square root of 4, which equals plus or minus 2. But the reason that x can't be minus 2 is because if you have a look at what x is a length. So that length isn't going to be minus 2, that's going to be a positive value. So x equals 2. So then what we do, once we know that x is 2, we've got to find the minimum value of p. And p is given to us by this thing here, so we substitute x back into it, and we get p equals 8 divided by 2 plus 2 lots of 2. So that's going to be 4 plus 4, which equals 8. Finally, find the width of each rectangle when the perimeter is a minimum. Find the width of each rectangle. Give your answer to the nearest centimetres. So, if you have a look at this, the width of the rectangle is going to be this thing here. So we know that x is 2, and y is the width. So here, we've got to find, well, we've got to figure out that y is the width. We substitute x equals 2 into this. So y equals 16 minus pi times 2 squared all over 8 times 2. And you do that in your calculator. So 16 take away 4 pi divided by 16, y equals 0.215. And so sorry, that's in meters. So it's 2146. So if we round to the nearest centimetre, that's going to be 21 centimetres. So let's just double check that. Yeah, 21 centimetres down there. Which brings us to our last one. So the first two, again, I've been able to manipulate algebra to get this, and then once we've manipulated the algebra, all we're going to do is we're going to no doubt find the minimum using calculus. Yep. So therefore, we're going to differentiate it to equal 0. The manufacturer produces pain relieving tablets. Each tablet is a solid cylinder. Given that the volume has to be 60 millimeters cubed, so it tells us what the volume is, and we have got this diagram here. So let's say that the volume is actually pi times radius squared, so it's going to be pi x squared times by h, and that equals 60, and that gives us 1 mark. So express h in terms of x. So we're now going to rearrange it to get h equals, so h equals 60 over pi x squared. Show the surface area A of the tablet is given by this thing here. So the surface area is going to be the top and the bottom. So it's going to be 2 lots of pi x squared plus the curved surface which we've done before. So that's going to be h times by the circumference, which is pi times d, which is pi times 2 lots of x, so 2 pi x. 2 pi x times by the height. But we know that the height is this thing here, so we substitute that in. A equals 2 pi x squared plus 2 pi x times by the height, which is 60 over pi x squared. So if we have a look, 2 pi x squared is our 2 pi x squared, so the area equals 2 pi x squared plus 2 times 60 is going to be 120. The pi's cancel out, this x cancels out with one of these x's, leaving you just one underneath, which is what we've got there. So those are the first 4 marks. And then we go back to do the rest of our question. Use calculus to find the value of x for which a is the minimum. So we've got to differentiate and find the value of x. So let's change that into x to the minus 1. So dA by dx equals 4 pi x. Then we're going to bring the minus 1 down, so that's going to be minus 120 x to the minus 2, which we're going to bring underneath, then set it equal to 0. So if we set it equal to 0, 0 equals 4 pi x minus 120 over x squared. So if we bring this over to the other side, 120 over x squared equals 4 pi x. Bring this up and bring that down, and we've got x cubed equals 120 over 4 pi. So if we divide through by 4, that's going to be 30 over pi, and it's going to be the cube root of that. So x equals the cube root of 30 over pi. Given your answer 2, I'm not sure which. So if we just work that out, and we get 2.12. Now before we carry on, we'll check the answer there. So 2.12, yeah. Or the cube root of 120 over 4 pi, or 30 over pi. Either one is absolutely fine. And calculate the minimum value of a. So, just like we've done beforehand, except we've done it all in one, we then substitute in our value of x into our a here, and we then work out what the value of a is. So 2 times pi times by your answer squared plus 120 over your answer, and you should get 84.84. Giving your answer to the nearest integer, so that's going to be 85. Then we've got to show that it's the minimum, and exactly the same way as before, we differentiate a second time. We substitute in our value of x, which is 2.12, and we should end up getting a positive value if it's a minimum. So d2a by dx squared. If we go back to this thing here, differentiate again, you get 4 pi. And then if we bring the minus 2 down, it's going to be plus 240 x to the minus 3, which you bring underneath. And then we substitute in. And if it's a minimum, I would just automatically say d2a by dx squared is going to be greater than 0. Therefore, a minimum. And that's it. So the key thing to take from all this calculus stuff is that when it says use calculus to find either the stationary point, the minimum, or the maximum, every time just differentiate so that it equals 0. Now, if you can sort of keep that in mind, you should be reasonably confident about getting most of the marks on these questions. The other thing that you have to do is whenever it gives you a scenario like we have done here, it will give you some information. You've got to formulate your own equation and set it equal to that. If you can do that, again, you get some of these early marks as well. And if you've got time, at the end you can play about with the algebra to make sure that you get to either of these answers. Okay, best of luck.